Hey, John here. Let's talk about this function called assert. First of all, let's make sure you understand what assert3 means, okay? I type man3 assert. This is section 3 of the online Unix reference manual for the command assert. That's what the 3 in parentheses mean, and then you can see it again on the top of the manual page. So that's what the title of this video really means, okay? And as a typical man page, it says, okay, assert, it says abort the program if an assertion is false. Okay, great. What do you do? Well, I have to include the assert header file, the function, I got to call it. It looks like this. It says assert, and then I got to give it a scalar value that represents an expression. And yeah, what does that really mean? I'll show you in a second. Okay, so what does it say? It helps find bugs in your programs. And, if this expression here is ever false, okay, in other words, if that expression equals 0, then the expression is false, okay? If that happens, assert will print an error message to standard error, okay, and then it'll kill your program by calling abort. What does that mean? That means go look in section 3 for the abort function if you want to know what that is, okay? The short of it is abort will stop your program and it'll create a core file if you have your shell environment set up to allow core files to be created, which, by the way, for the purposes of this particular video, I have mine turned on. Okay, so it says the error message includes the name of the file and the function that contains the assert call. It also includes the source line number, okay, in the file, and the text of the argument. The text of this expression will come out. So, for example, it'll look like this. Here's the name of your program. Here's the source code file. Here's the line number. Here's the name of the function that was executing when the assertion function was called. So some func, if we look at the source code of this example that this guy wrote, has to call the assert. This is actually a macro. The assert macro, okay, somewhere in here on line 16, right? And then it prints an assertion has failed, okay? What's in this quotes is the expression that's inside here. So what we can know for sure is somebody wrote, for the purposes of this documentation, a file called sumfile.c, and on line 16, there was an assertion statement, right, that looks like this up here. And the scalar expression in that assertion was exactly this. So presumably this sum func has an integer variable that's passed in maybe, and if it ever equals 0, it's okay. All right. And if it's ever non-zero, it's not okay. All right. We'll talk a little bit more about that in a minute, but that's the expression. So what this really means is somebody writes this function and he says, you know what? It's running along and something bad happened. Like there's a variable that has a value that's just totally illegal and there's no way to fix it. And it suggests, if you write a program, there are situations that you just cannot recover from. A pointer that's null in some routine somewhere that can't, in theory, could never happen, right? Because you're a genius, you wrote all the code, and you debugged it, and everything is perfect, and it's not possible for some pointer variable to ever have a null in it, right? We all know that's, I'm sorry. None of us are super geniuses. Every bit of code we ever write is perfect, right? So you might, in a case like that, put an assertion in there and say, assert that the pointer in question is not null before you start using it and stuff like that. Because if it ever does become null, there's a complete design, there's a design flaw or an implementation flaw, a structural damaged thing about your program that can't theoretically ever happen. That's what these are for, all right? You don't use assertions to debug user input and things like that. No, those are user errors. Assertions are used to deal with implementation flaws in your own code, things that can never happen no matter what. That's what this checks for, okay? Why? Because they still happen because we make mistakes. All right. Last note down here, it says, by the way, if you define a macro called ndebug before you do the pound include on assert, then what happens is the assert macro will be removed. And all the assertions that you put in your code, well, just you can leave them in your code. They just will disappear. The compiler will remove them, right? The way that works is the macro itself, that is the assert macro, is defined as nothing at all. So when the compiler compiles your assertion, it removes the code from your file, all right? That's a standard kind of a technique for debugging sorts of things, all right? That way you can leave all this debugging stuff in your code, even in a production release, that you don't necessarily, maybe you don't want to have the debugging stuff in there. And yet you can still leave the source code in there so that you don't, show of hands, right? I have mine up. How many people have, had a perfectly working program? You remove all your debugging code and it's not working anymore, right? Well, leave it in there, okay? So if you use asserts and you say pound define and debug right before they include, they will be removed without damaging all your files in your source code, okay? That's what that's all about. All right, so let's look at a little program that I wrote that's about as sophisticated as the little demo you saw there. This is a C++ code. So therefore, rather than including assert.h, I'm going to pound include C assert, okay? So if you're going to include standard C library headers, there's C++ variations of them, right? You could just as easily said just pound include assert.h there, okay? But just FYI, so this is C++, right? So what's going to go on here? I got a main, and it's going to call this f function 4 times, and it's going to send it these values here, and then main's going to return 0. Everything's okay, okay? Let's look at this function here. I got a function called f. It has a parameter called I that's an integer, and I'm going to assert that I must be greater than 0. If this is ever not true, I want my program to die right then and there because, oh no, something terrible has happened. Not a user's fault. It's not an error in a file. This is because my own code did something wrong that no user could ever fix. This is an implementation flaw, right? Because I accidentally did something that my own code cannot tolerate. All right. Again, that's what assertions are for. They're not to interact with users in any way. And I'll show you the messages are not actually clear to users. That's why. These are for developer type things, all right? So obviously this thing will fail when this assertion is checked, right? Right. If the assertions are true, then we just simply continue on and we print out, yay, my parameter is all good, and we keep going. All right. So there's my little program here, right? Let's go ahead and compile it up and run it. Oops. There's no assertion for you typed it in wrong. Okay. The first two worked. It finally got to the point where I sent it in a -2, right? And there's my assertion. Function is the program that I ran, assert1. All right. There's the file, line number 6. This function has an assertion that has failed, and the assertion is that. All right. It also says it dumped core. Right? Now, again, if you have core files turned on in your shell environment, you can then say gdb, assert1, and core, right? Now, look at this. I'm not running assert1. Now, in this particular case, this program is so trivial and will fail the exact same way every single time. I could just run it with gdb and run it again and then, see it die while I'm running it. Well, let's go ahead and do that. All right, so it comes along and says, it's okay, it's okay. It prints out the assertion message, and GDB says, oh, bad thing happened. Somebody called GI raise in some library that I don't have any idea where that came from, right? I can type where, and it'll tell me all this great stuff. Main in this file, oops, on line 14 called F, and then F on line number 6 called assert. Right? And assert's a macro. All right? Assert when you don't have it disabled with that ndebug thingy that they were talking about. Actually ends up calling this thing the GI assert fail. All right? So it's kind of starts getting nebulous down here, right? Because this is inside the library. The operating system stuff's going on in here. But you can clearly see there is something that you recognize as an assertion failure, and also talks about assertion fail, a base and the abort and so on. So what then happens here is you can clearly see the I greater than 0 message, right? And you can also see that when assert prints out its error message, right, it needs to know the line number and the name of the function. You can actually see those in here as strings and stuff like that, okay? So this is what happens if you run GDB on a program that does an assert while it runs. But we have a core file. Sometimes when you run a program, it's very difficult to get it to fail, right? You got all the things debugged, and then once every 3 months, the thing fails. Oh, I got to wait another 3 months before it fails again in order to figure out what's going on. Well, in those situations, if you allow the system to create a core file of the process when it dies, it takes a snapshot of everything that was going on in there. So if I type GDB and I say assert1 and then I type core, this will tell me what happened to assert1 when it dumped core, 3 minutes ago. I don't have to run it again. So if it's something that happened only once, and there's a core file, I can say, where did it die when it was running? Notice I didn't say run in here, and it never ran it. I asked what happened when the core file was created, and it tells me the exact same thing. So if you have a situation where you get an assertion failure, and it's hard to reproduce, but you got a core file, that's why... that's what they're for. Okay, it's for debugging after the fact. All right, so let's say we do define this and dbug. Now, I think it's debug. And the man page for this thing did say it's not a good idea to shut these off. Okay, why? Because remember the purpose of an assertion. It's supposed to be used to check things that, theoretically can never happen. Okay? Therefore, you really shouldn't shut these things off, right? I just shut it off now, and I run the program, and you can clearly see the assertion's not being checked, and it does go ahead and proceed and process this totally illegal value. Okay? So the man page is not lying. This is what happens if you define that. It removes the debugging stuff, okay? Now, why would you want to remove assertions from one or more files, right? Realize that I can define and debug in one file that has an assertion in it, and I can still leave them all on in other files, right? So this is, only in the file right here that this would apply. In any real project, there's hundreds of files, so you can turn some on and leave some off. That's my point. Why would you ever really want to shut it off if it's totally unsafe to run your code without that in there? Okay. Well, it takes time to evaluate this expression. If your program is super duper 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 high performance and highly time sensitive and things like that, and you really much have removed all possible causes of problems, then it might actually be okay to remove them. All right. But again, just like I said before, sometimes removing your debugging code, you wreck your file. Or you might want to put them back in, 6 months from now. And you don't want to have to go back and re-edit all your files. It's just a pain in the butt, right? So it's easy to turn them on and off with this macro is the point, right? And the only time you should ever shut off such a thing is if you have a performance-related problem with it. Now let's look closely at what it means to put an expression in here, right? So you're going to put I greater than 0. Maybe you can also say I less than 100, okay? That's fine. Oops, in VI. Now it has to be between 0 and 100, and of course that'll fail right on the first one. So maybe I'll put less than 600. All right, so that way it won't die in here, right? So let's go ahead and run that one. And it works on the -2, okay? Why? Because it has to be greater than 0 and less than 600. So now I see more of the expression, right? Well, that's great for me as a developer because I know what F is and I know what assert1, CC. I understand all this stuff, right? Well, what about a regular user? It's like getting a blue screen on an old Windows box. Worthless to any normal human being, right? It's just a bunch of crap. That means it's time to reboot your box, right? Okay. That's what assertions mean as well for most normal people, okay? Now, How can I dial this up for a normal person? Remember, the assert macro simply prints out the contents of this expression. To be honestly with you, it's so annoying that it doesn't tell me what the value of the I variable is. It really is annoying. I wish it did. It would be nice. Because, well, what is the value, right? That's what the core file's for, by the way. So if you do this and it dies and there's a core file, you can always type where, just like I showed you, and it'll tell you what the variables are and the functions and stuff like that. You can do detailed inspecting and printing out variables and stuff. I got another video on how to use GDB for stuff like that. You can look at if you want. I'll put a link to it below this in the description below this video. All right, but there is something we can do. Right? What does it really mean to write a conditional expression in C++ and C? And all the other languages, they use this style, this grammatical notation, right? Anything that is 0 is false, right? That wasn't what it actually said in the man page, right? Right? It says if the expression is false, as in the whole expression is 0. Then it fails and prints the message and kills your program, right? If it's 0, it's false. If it's not 0, it's true. So if I put that in there, what's the value of that expression? When I is 123, right? Is it greater than 0? Yes. That means that this little comparison operation right here, this part of the expression, is equal to 1. That's what it really means in C. I greater than 0 is an expression that is evaluated, and it's reduced to the numeric value of either 0 or 1. It's true, so the value of this expression I got highlighted right there is 1. Okay? So that's true. And what's this? I less than 600. When it's equal to 123, is that true or false? It's true. Therefore, this is 1. Okay? And what? This is 0. Well, 0 is 0, and 0 is false. So this is true and false. So if I compile this, it doesn't mind. Run it, it fails the assertion on the very first try. Why? Because anything at all ended with 0 is false. Okay? Sometimes you literally put assert 0 in your code. You might have else if, giant piece of code in here with checking all sorts of things. And then you got else, it's absolutely impossible to get here. There's no way that this should have ever happened. You might put an assert 0 in code like that. Why? Because if you don't, your program might continue on and do all kinds of crazy stuff that no one would ever know because you never bothered to report it or anything else. And because you didn't assert, you never got a core file. Therefore, you can never go into GDB and find out what happened in the first place. And then you can't debug your code and look like a genius to all your peers and your boss, right? So what else is true and false, right? So far, so good. But this is really only good for the developer. You're at a giant program with hundreds of classes and hundreds, if not thousands, of functions and things like that. You can't remember every single thing perfectly, right? So what else can we know? What if I put in this? What's the difference between a 0 and a 0 in quotes? Anybody? Bueller. Okay. A 0 in quotes is a string. The value of a string is the address of the array within which the string is stored. That's why the assertion doesn't fail here. Don't be a fool and think that a string with a 0 in it means 0. This isn't PHP, okay? That's a string. I could put hello in here. Oops. All right. And again, this and hello, all right? So what is that? What's my point, right? Well, I happen to know, right? Any string literal, anywhere in a running C program, will be stored somewhere in the memory. And it turns out that string will be stored in a memory address that is never going to equal 0. You know why? Because the address that is equal to 0 is the value of the null pointer. That is explicitly reserved for null. All right? We can prove that by putting null right there. Okay, and now the assertion will fail right away because null is 0. Hey, look, it failed on the very first time, okay? Null is 0 or false, okay? Any string literal is never going to be false. And why am I beating this point here, right? Well, I can put any text I want here. Because I got an assertion here, it tells me a lot of stuff. But it really doesn't tell me, in English, in plain terms, why I decided to put that assertion in there in the first place. So I can print more information is the point. Anything ended with a text string. The text string will not cause any problems. This, with a text string, this expression here doesn't change in any way. Because just like this expression ended with 0 is always false, all right? That expression ended with 1 is the same thing as just simply that expression. Okay? This provides no value, no input to that evaluation of that expression, right? So I can say something in here, meaningful is my point, when I write an assertion like, I is supposed to be, some useful thing, blah, 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 right? This program here in this example is so trivial, it's hard to actually say anything useful in this particular example. What did I do wrong here? Oh, I forgot to put the semicolon at the end of it. All right, and again, it just prints out that string. Okay, so this is all there really is to assert. The rest of it is how you're going to use it, and how creative are you going to be with this expression. Can you pop in a string like this, so when assertion fires, you say something like, call John, or whatever you want to say in there, so that it's a little bit more meaningful than I greater than 0, when somebody who doesn't even know what this function even is, or why it's there, or who wrote it, put it in there first place, all right? So that's all you got to do. Use wisely. Thanks for watching. See you next time.